Right, guys. Good evening to everybody. Hope you had a great weekend. Hi, in our last class, we have discussed about filter sharing options, um, and also we have discussed different types of filters, be it quick filters, context filters, and also all the different types of filters. We also discussed about parameters, how we can use parameters along with calculated fields. And we have discussed about filtering at a data source level, and also uh, filter sharing on the data source at a sheet level. So we have also discussed about filtering across multiple data sources as well. Okay, so we have seen differences between parameters and quick filters. So finally, we have looked into some filtering best practices um, while performing all the filtering activities on Tableau. Okay, so uh, so these are the different things that we have discussed in our last class. So do you have any questions on those topics? Yeah, along with that, we also discussed about some cascading filters. Are you able to hear me?
Yes,
Are
correct.
you,
Yeah.
yeah, so we
Yeah, I
have
can hear
discussed
you.
about some cascading filters as well. Um, yeah, have you gone through all those topics? Okay, if you have any questions, you can write to me, so I'll respond to that. So now we'll discuss about joins. So what are the different join types that are there in Tableau, and how we can use joins in either blending different tables or databases in Tableau. So basically, what is a join? Join is a query. Join is a query that combines the data from two or more tables or sheets or files in a single data source or across multiple data sources based on the join condition. What is a join? Join is nothing but a query that combines the data from two or more tables, two or more sheets, or two or more files uh, in a single data source. So tables can be in a single data source, or they can be across multiple data sources as well. So joining across multiple data sources is available from Tableau version 10. Before 10, so you can only um, join tables in a single data source. So you can also define a join condition to join those tables. So uh, while performing any joins in Tableau, so there are two rules you need to take care of. You need to keep in mind while performing joins. So the first rule is both the tables should have a common column. So you're joining two tables, right? So when you're joining two tables, those two tables should have a common column in between them. So you should have those two tables should have a common column. That is the first rule. The second rule is based on the common data type in both the tables, we have to perform a join. Okay, so the data type should also be the same in both the tables. The first rule is the two tables should have one common column. The second rule is there should be a the the data type should be common in both the tables for this column. Okay, so these are the two rules. If any one of the rule is satisfying, then it is possible to perform joins. So it is a or condition. So if any one rule among these two rules are satisfying, then we can perform a join condition. Okay, so looking at the joins, so uh, there are two types of mainly join types are divided into two types based on the join conditions. Okay, depending on the join conditions, joins are divided into two types. What are those? Equi joins and non-equi joins. One is equi join and other is non-equi join. What is an equi join? So in a join condition, if you use the equal operator, that is equal to, then such a kind of a join is called as a equi join. So when we use a equal to operator when joining two tables, then such types of joins are called equi joins. So what are non-equi joins then? So in any join condition, apart from equal join condition, if you use any other operator like not equal to, greater than, less than, less than or equal to, or greater than or equal to, so all these operators, when they are used in a join condition, then such type of a join is known as a non-equi join. So basically, there are two types of join depending upon the join conditions that we define between two tables. So one is equi join, other one is non-equi join. Equi joins are the ones which use an operator of equal to. All the rest of the other operators are used in non-equi joins. Okay, so uh, all these equi and non-equi joins are further divided into inner join, outer join, and self join. Okay, so uh, either it be a equi join or a non-equi join, they are divided into inner join, outer join, and a self join. These are the three types uh, that all these join types are divided into. Okay, so there are two join types. So there are two join types based on the join condition. So they are further divided into three types. Okay, one is inner join, one is outer join, and other one is self join. Okay, so this outer join is divided into three more types. So one is left outer join, other is right outer join, and the third one is full outer join. Okay, these are the different types of joins that we can define in Tableau. Okay, so uh, there are two ways that you can perform these joins in Tableau. So if you if you want to perform any join, so there are two ways to implement these join types. So one is automatic way and the other one is manual way. So Tableau automatically takes the join condition if both the tables contain common column with the same name in the same case. So if two columns in the tables in for example, if we take two tables and we are trying to join these two tables, and the common column, if there exists a common column which is having the same name in both the tables, for example, um, a region in one column is having the same field in another column in another table. Okay, so in table 1, if there is a column called region and there is a table uh, uh, another table wherein it also has a column called region, and also it is in the same case, that means in first table, the data, the name of the column is region, denoted by capital R, and in the second table also the column name is same region, starting with a capital R. So it has the same case and also the same name. So in those cases, Tableau joins are automatically implemented. So there is a second way where you can implement joins when there is some mismatch in these conditions. So the conditions are there should be a common column, and the common column should have the same case, same name. So in manual way, we need to define the join condition manually if both the tables contain common column with a different name. Okay, in different or in different case. So in few scenarios where the tables contains columns which are having different names or different case, so in those cases we can perform manual uh, joins. So we'll see one by one how we can do that. So in Tableau, by default, inner join is the default join. So whenever you perform any join in Tableau, inner join is the default join condition. Okay, so we'll first see one by one what are these different join conditions. Right. So we'll first see inner join. So an inner join combines the data from two tables. Here, imagine that there's a table called A and table called B. So an inner join combines the data from two tables and it displays only the matching records or common records. So the matching records from table A and matching records from table B are in this area. So if you perform an inner join, only the matching records or common records are sent into the resultant set. Okay. In inner join, the resultant set of two tables will have only the common records or matching records between the two tables that you are performing the inner join on. And by default, uh, in Tableau, so inner join is the default join type. So inner join is the default join type. So we'll see how we can perform this join. So we'll open a new worksheet, open a new dashboard. So we in this task, we'll try to implement inner join in Tableau on Superstore uh, data source. Okay, so we are able to connect to Superstore data source. So we'll go to connect to data, and then select the file type, then select the database data source. We'll click on orders. So orders is the table 1, and we also click on returns. Returns is another table. So returns is the table 2. So while clicking both the tables, so we an automatic join has been established here between orders table and returns table. So this is nothing but a inner join. So inner join is the default join condition in Tableau. So um, the common fields here are order ID in both orders and returns table. This is how we can establish a inner join. Similarly, when we look at auto joins, there are three types of auto joins: left auto join, right auto join, and full auto join. So here, uh, looking at left auto join, so left auto join displays the complete data from left table and matching records from the right table. Okay, so when we take left join, so what it displays is, so if there are table A and table B, okay, so the left auto join displays all the data from the left table A and the matching data and the matching records from the right table. Okay, so a left auto join returns all the complete data from the left table and matching data or matching records from the right table. So the matching records from the right table will be in this area, in the in this area, and you only the complete data from the left table would be in uh, in this area, in this area. Okay, so so if you see the same implementation of a left join here, left outer join, while establishing a join condition in Tableau, so we'll use the same uh, connection and also same tables, orders and returns. So we'll click on the join icon here and select left here. So this will actually return all the tables from orders and matching tables from returns here. Okay, so this is the left outer join, left outer join. So we also have right outer join here. We also have right outer join. So what is a right outer join? So right outer join displays complete data from the right table and matching records from the left table. Okay. So it is nothing but the vice versa of the left outer join, right? So you'll have all the records from the second table, right table, and the matching records from the first table. So if you see that in an example, so by 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 choosing right outer join like this, so it will have all the data from returns table and matching records from the orders table here. Okay, so this is about the right outer join. So now we have full outer join. So we have full outer join. So what does this show? So it displays the complete data from both the tables. Okay, so when you use a full outer join, um, joining two tables, it shows the complete data from both the tables. So what is the full outer join output? So full outer join output is only left plus only right plus matching data. Okay, so the full outer join output is only left and only right and matching data. So what is only left? Only left is left outer join minus matching data. Left outer join is complete this data, and only left means left outer join minus matching data. So only right means left outer join minus matching data. So finally the full outer join output is left outer join plus right outer join minus matching data. You can also say that. You can also say that left outer join plus right outer join minus matching data is full outer join. Okay, so we can get a full outer join by using the equation left outer join plus right outer join minus matching data. Okay, so this is about full outer join. So if you see the same in example, this example, if you take full outer join, so this will return all the data from tables, orders, and returns. So it will have all the records from both the tables, orders, and returns. Okay, so this is about different outer join types. We also have self join. We also have self join. So what is a self join? So when you perform a join on the same table itself, we call that type of a join as a self join. Okay, so we also have self join here. So we have discussed about inner join and outer join. We have self join. So what is a self join? So performing a join on the same table is known as a self join. Okay, so we'll see how we can perform a self join. So we'll use the same superstore sales. Um, we'll click on the orders. We'll remove these returns in here. We'll have the orders table, and click on orders table again. You click on the orders table again. Okay, so we'll choose customer ID. In both the tables. And this will create a join condition. Okay, we'll create a join condition. So here we are joining two same tables with each other, one table with each other, and those tables are one and the same. So when we perform a join to the same table itself, it is known as a self join. So we are joining orders table with orders table with a common dimension called customer ID. Okay, so this type of a join is known as a self join. This type of a join is known as a self join. Okay. So we are using an operator called equal to. So whenever we are using an equal operator, so in all these conditions, we have used an equal operator. So when we use a equal operator, then that type of a join is called a equi join. So when we use a equal operator, so there are two types of joins, right? Equi join and a non-equi join. So whenever you use an equal to operator when joining two tables, then that type of a join is called a equi join. So this is a equi join. Also, in the previous examples, also we have used equi joins. We have used equi joins. So what about non-equi joins? What about non-equi joins? So we'll see with examples. We'll try to display the status of unmatched orders. So in the same table, we'll try to uh, display unmatched tables, status of unmatched orders. So for this, so there are orders and returns table from Superstore sales data. So we are changing that in data source tab. So here we'll click on this icon and um, we'll change the operator to we'll change the operator to not equal to. Okay. So now what has happened is, so we'll go to the sheet and see the difference. So here in this sheet, uh, we'll drag the status from returns page into rows. So there are two pages here, returns and orders. Okay, orders and returns. From returns, we'll drag status into rows and order ID from orders page into rows. The order ID from order ID into rows. Here, what we are getting is only those items which are returned. Okay, so we have orders table and returns table. So just observe the data. So we have orders table. So this is the data of all the orders in Superstore sales data. So these are all the orders. So within these orders, after ordering, the customer might have returned some of the products. So this is the data about all the return products. This is the data about all the return products. So based on order ID, based on order ID, so we are using a not equal to operator. That means we will get only those orders which are not matching from uh, not matching in these both the tables, orders and returns. Okay, so you will get only those returns which are not matching in orders and returns table. Okay, so the resultant set here is the returns which are not matching in both the tables,
Auntie,
orders.
can you explain that one more time? I didn't understand properly. What did you do? Like the orders and returns?
Yeah, okay.
Thank you.
So here
Mhm.
there are I've connected to the Superstore sales data source, and in this we have orders and returns table. So these are the two tables. So this data is contains all the orders data. So whenever a customer orders some product, so these are the values for all the orders table. So with after ordering, a customer might have returned some of the products. So this data contains all the return products. So the common field between orders and returns is order ID. Okay, so that means order ID 65, 69 have been returned. So we'll see those order IDs in orders table as well.
Okay.
Okay, so these have been returned back. So this is showing only first 10,000 rows. So there should be somewhere an order ID called 65 and 69. So this will actually, these are the products which are returned from returns table. Okay, so by defining a not equal to condition here, not equal to condition here, so this join condition will check order IDs from both orders table and returns table. Okay, so it will return only those order IDs which are not equal to in both the tables. Okay, so it will see for order IDs in both orders table and returns table. So if they are not matching, then only it will return in the resultant set. Okay, only those orders which are not matching in both orders and returns, then only they will be returned in the resultant set. Okay, so
Yeah,
this
thank you.
resultant set will contain only those orders which are not matching in both the tables for the order IDs. Okay, so in such scenarios you will be using non-equi joins. Okay,
Yeah, got it. Thank you, Kranti.
right. So these are the different order join types. So basically, to sum up, what are joins are? Joins are a way to relate two or more tables together from one database into a single resultant set. So here, what is the join? Joins are a way to relate two or more tables together from one database or a multiple databases into a single result set. So here we have related two tables here from a data source, single data source called Superstore sales to get a resultant set like this. Okay, so this is the way that we use in joins. So they require a common field between the two tables that you are joining. So whenever you perform a join, it definitely requires a common field. So common field here is what? Common field is order ID. Okay, order ID is the common field. So the joins require a common field between the two tables when you are joining. So this common field will define the relationship between the rows. Okay, so this common field will actually define the relationship between the rows. Okay, this common ID, common field will usually be a key field or a indexed field. So either it will be a key field or a indexed field mostly. So in other words, if you can say that joins can be used as a way to retrieve additional columns to your resultant set from a different table. Okay, so if you want to bring in an additional column to your resultant set, um, then you can use joins. Okay, when you use joins, you can retrieve additional columns to your resultant set from a different table. But before that, you need to establish a relationship between these two tables by using a common field. Okay, right. So in an example, if you can see, so consider these two tables, sales tables and product table. Okay, so the column that the two have in common is the product field. So product field is the common column between sales table and the product table, right? But the values aren't exactly the same in each table. Here 1, 2, 3 are the values in product table in sales product field in sales table. However, in product table, the product field has 1, 2 and 4. 3 and 4 are mismatching. 1 and 2 are matching values between product field in between sales table and product table. Okay, these two are two tables. Product is a common field, and the entries the entries are 1, 2 are common values between product field. Okay, so in this example, if you see different join types, uh, we can understand this concept better. So if you change the join logic between two tables, it will change the way Tableau will display the result. So we have seen that if we change the join type, so changing the join logic between the two tables is changing the way Tableau displaying the result. So if we take left join, so it will take only those values from orders only, and also the matching values from results. So similarly, if you take right, it will take all the values from the, it will result all the values from return tables, or only the matching values from orders table. So matching, changing the logic, join logic between the tables would change the way Tableau would display the resultant set here. Okay. So if it is an inner join, so we'll see one by one. So if it is an inner join, so we'll see that with an example here. So if it is an inner join, um, which is a default join in Tableau, so then only the records will return, which will be matching, um, from the, here in this example, those products, the inner join will return only those products uh, which will match from the number, for the number products. So 1 2 are the matching values, and will the inner join will be returning only those products which are matching between these two rows. Okay, what are the matching rows between these two tables? 1 and 2. So only those rows would be displayed in the resultant set. So if you take inner join, an inner join can be helpful to only return back transactions that have been recorded in both the tables. In this case, in this example, a list of all products that have been sold to customers. Okay, so these are all the, so sales means those are sold to customers, right? Okay, so in, if we are getting, if you are using a inner join, we will get list of all the products that have been sold to customers. Okay, so um, 1 2 are the are the products that have been sold. 3 is also there, but we don't have a product called 3. So in this table, so in, by join, creating an inner join, we are getting a list of all the products that have been sold to customers. So when the details are available for each sales transaction. Okay, so so the condition here is when the details are available for each sales transaction only, then it is returning this. Okay, so if you perform a inner join on these two tables, um, the resultant set would be the list of all products that have been sold to the customers when the details are available for each sales transaction. Okay, so the details are available for 1 and 2, and uh, and these two are sold. So the inner join will return only these two rows in the resultant set. Products that have not been sold would not be included in the result. Okay, so products that have not been sold. So what are the products that have not been sold? 4. Tableau server, Tableau personal and professional has been sold. So Tableau server has not been sold. So using an inner join, that would not be in the resultant set. That will not be included in the resultant set called inner join, for inner join. In this case, there would be there would be a sales transaction that would not be returned because there is not a matching record in the product table. Okay, there will be sales transaction that will not be returned in the inner join result because there is not a matching record in the table, in the product table. That is sale of product 3 to customer C. So this will not be in the resultant because there is not a matching record. There will not be a matching record in the product table. So is that clear? Is that clear here? How you'll get a resultant set in the inner join?
Yes, class.
Yeah. So if you use a left join, so if a left join was requested, so Tableau would return all the rows from the left table and only the matching rows from the right table. Okay, so it will return all the rows from the left table. So 1 2 3 are the matching rows from the left table, and only the matching rows from the right table. So matching rows from the right table are 1 and 2. So 4 is not matching, so it will return a null here. Okay, so if a left join was requested, so Tableau will return all the rows from the left table, which are 1, 2, 3, and only the matching rows from the right table. So what, which is 1, 2, Tableau Professional and Tableau Personal. So in the example, we will result this the example will would show the results of sales on the left, sales on the left, and product on the right. Sales on the left and product on the right. So um, these two tables are indicated by different colors like this. So blue is sales table, green is product table. Okay, so we will have um, sales on the left and product on the right. Okay, in this example, the left join relationship more accurately reflects the actual sales transaction that have been occurred. Okay, so here this left join reflects the actual sales transaction that have been occurred. Okay, while the detail is not included here. In the detail, it is not included because there is no match between the sales of product 3 to the customers 3. Okay, because we have performed a left join. Okay, so it is not included in the result since the record was not in the table on the left. Okay, so this record is not in the left table, so that we have that's why we have excluded this value here using left join. Okay, so going back to the right join, so it is nothing but a similar logic to left join. So a right join uses logic similar to a left join, but changes the direction of the join. Okay, it is just a direction of the join. So instead of left table, we have to take the right table. Okay, so in this case, the right join would return all the rows from the table on the right and only the matching rows from the left table. So if you use a right join, it would return all the tables from the product table and only the matching rows from the left table. So matching rows are 1 and 2. Okay, so it will return only 1 and 2 rows and all 1, 2, and 4 rows from product table. Okay, in detail it will have Tableau Professional, Personal, and Server, and in product it will have 1, 2 blank, customer it will have AB blank, and sales it will have 5, 10, and blank. Okay, so it is nothing but a flip of a left join. So in this example, a write down will return what? It would be helpful in finding the which products have not been sold. Okay, so if you want to know which products have not been sold, then we can see using a write join. So because we will have Tableau server and a blank data for Tableau server in left join resultant set. So we can see which products have not been sold using write join. So basically, if a database does not support a right join, the same result could be achieved by placing the product table on the left and then creating a left join to the first tables. Okay, so basically we can flip the if at all if you face any problem while creating a right join in the database, if or the database doesn't support a right join, you can interchange the order of each table. So the second table can be placed in the first place, the first table placed in the second place, and you can perform a left join because this also gives you a right join resultant set. So order in which you place will also uh, will result in the way in which you get the output. Okay, finally we'll see what a outer join is, full outer join is. Okay, so this will return all the records from both the tables and would leave nulls where there was not a match between the two. Okay, so it will return all the records from both the tables. Okay, so and will also leave blanks where there is not a match between the two. So there is 1, 2, 3 in sales tables, not 4. However, it will show 4 here. So because product table is showing professional, personal, and Tableau server. So there are no values for customer and sales fields in sales table. So it will show blanks here. However, it will include 4 and Tableau server here. In product, it will show 4 value, and detail it will show Tableau server value. So joining multiple tables can be easily handled in Tableau, like this. However, a relationship should be defined for each table included in the data source. Okay, so we have to note here that there can be multiple clauses within a each join, and clauses can be different when joining more than two tables. Okay, so um, we can define different types of joins while creating any join type here. Okay, while creating the relationship between the joins. So we also have to define the relationship between the common fields also, whether equal to or not equal to. Okay, so these are the different types of joins that are there in Tableau. So you may get a common question here. So of how to define a relationship, or which type of a join you should use for which type of a data. So to get a clarity of which type of join should be used for which data type, so we have to know the concept of cardinalities. So if you know the concept of cardinalities, you'll be able to define the data, the join types for different data. So we look into cardinalities now. So, so join, what is a join? So join is nothing but a relationship between two tables. So join is nothing but a relationship between two tables, right? So um, however, if you want to know the type of relationship or exact relationship or correct relationship between two tables, then we need to identify the cardinality between two tables. Cardinalities is nothing but what is the relationship between those two tables. Either it is one to one, one to many, many to one, or many to many. Okay. So if you want to know the type of relationship, so you may be confused to which type of join you have to use in while defining the join tables. So for getting a clarity, you have to know the cardinality relationship between these tables. Okay. Um, okay. So by identify cardinality between the two tables, you can you will be able to uh, define a relationship, join relationship between two tables. So there are the cardinalities are basically divided into four different types. Okay, they are one to one to many to one, and many to many. So these are the four different types of cardinalities. Okay, so what is one to one? So if one value in the first table is associated with or related with maximum of only one value in the second table, then such type of a cardinality is known as a one-to-one cardinality. So for example, a person will have only one passport in ideal scenario. So this type of a relationship is cardinality is one-to-one cardinality. So for such type of all the relationships, you will define the join type as inner join. Okay. So if one table uh, if uh, if one person has a one passport, then it is one to one relationship, right? So um, the relationship between two tables can be identified by cardinality between two tables. So um, if one value in the first table, okay, if the one value in first table is associated with only maximum of one value in the second table, then such type of cardinality is known as one to one cardinality. So in such type of scenarios, we'll always use inner join. So there's also one to many. So if one value in the first table is related to maximum of multiple values in the second table, then such type of a cardinality is known as a one to many. So one country has multiple states, right? So in such type of scenario, so it is one to many relationship. So the rightmost table has more data. So you will use right outer join in such type of cases. Okay. So for example, we have a country and a state table. So country has more one country is only one. So however, within each country there are multiple states. So it's one to many relationship. So in such cases you will use right outer join. So there's many to one also. In many to in if many values in the first table is associated or related to the single value in the second table, then such type of a cardinality is known as a many to one cardinality. In such type of a tables where left table is having many uh, many relationship with the right table which is having only one relationship. So then the left table is having many relationships. So we'll use left outer join. Okay, in such type of a join, we'll use the join type as left outer join. So finally, we have many to many. If one value in the first table is associated to multiple values in the second table, which in turn one value in the second table is associated to multiple values in the first table, then for multiple values in the first table, we will be associating multiple values in the second table. Such type of a cardinality is known as a many to many cardinality. For example, students may opt to multiple courses, or multiple courses can be opted by multiple students. So the join type that we use here is full outer join. Okay. So based on the cardinality, we can define different join types. Based on the cardinality, we can define join types. So we have to note that in Tableau, there is no limit to number of tables to join. Okay, if you want to join these tables, there is no limit to for number of joins to join. So we can join more than 40 plus tables also. So there are two tables that we have joined here. We can join up more than 40 plus tables also. Okay. Dimension tables always contain less amount of data when compared to the measures. So whenever you join, so the dimension tables always contain less amount of data when compared with the measures. Measures will have a lot of data because they will be continuous in nature, and those will have a lot of data in them. So whenever you are performing joins, okay, you will have dimensions in less amount, measures in more amount of data. Okay, so this is about joins. So we can use joins to join multiple tables in Tableau uh, in a single data source or a multiple data source also. So this is about joining tables within a single data source. So here we have joined tables within a single data source called superstore sales. So we also have cross database joins. Okay, so I've told that there are two ways to join tables. So one is joining tables within a single data source, and joining tables across different data source also. So when you join tables across different data sources, then that type of a join is called as cross database join. That type of a join is called cross database join. So this is available only from Tableau 10 version. Okay, from Tableau 10, it is possible to perform joins across multiple data sources. It is known as a cross database join. Okay, so they execute at the data source page of Tableau. So data source page is this. Okay, they execute at the data source page of Tableau. So if you look at working mechanism of cross database joins, sorry, so I'll just give you a demo of that, then I'll show you working mechanism of cross database joins. So we have orders table uh, in training superstore sales. I'm adding one more database, access database, coffee chain, and coffee chain query is a table, and I'm defining a relationship. So we'll choose region, market. So I have defined a relationship here. Orders table is coming from superstore sales data source, and coffee chain query table is coming from coffee chain data source. So here, what are we doing? We are uh, we are joining tables from multiple data sources. This type of a join is known as a cross database join, and this feature is available only from Tableau 10 version. Tableau 10 version. So from Tableau 10, it is possible to perform joins across multiple data sources known as cross database joins. They executed the data source page of Tableau. Okay, so we'll look at the working mechanism of cross database joins. In cross database joins, first Tableau sends a query to each data source. Okay, so Tableau sends a query to each data source. So the data sources are Superstore Sales and Coffee Chain. It sends a query to each data source, and those query results will get saved into some temporary file in the form of a .tde. Okay. After sending the query to each data source, the query results will get saved in the form of some temporary file in the form of .tde extension files. So after getting data from multiple data sources in the form of temporary files, so you get the uh, uh, temporary files by querying each and every individual data source. Okay, so then all the results will get joined at the Tableau data source level to get a single join data source. So basically all the temp files will be created after querying each data source. So all these temp files will get joined at the Tableau data source level. Okay, at Tableau data source level, all the resultant temp files will get joined, and then it will give you a resultant single joined data source. Okay, so Tableau will uh, Tableau will first send each query to each data source separately, and they will be saved as a some temporary files. Okay, after getting the multiple data sources in the form of temporary files, so all those results will get joined at the Tableau data source level, um, whereas data source level in the form of a single data data source, single data source. So this will have the resultant set of all the combined temp files. Okay. Finally, all the sheets in Tableau will make use of the join data source. So if you use this sheet, any sheet, so those will, so if you use a new sheet, so it will contain the data source of the combined data from both coffee chain and superstore based on the or join you define. So this sheet will use that cross database join resultant set. Okay, right. So we have to note here that joins within one data source execute at the data source level. So if you execute any join for only one single data source, so those joins will execute at the data source level. So if you uh, if you perform if you perform a if you perform a join like this, so this is a order table and return table from same data source. So we are performing join for the tables within a single data source. So if you perform joins within one data source, um, the the join will execute at the data source level, Tableau Superstore sales level, at the data source level itself. Whereas if you execute, whereas if you execute, whereas if you execute uh, joins across multiple data sources, the joins execute at the Tableau data source page level. So execute at the Tableau data source page. They execute at this page level. Okay, data source page level. Okay, when you are using cross database joins. Okay, so here we have used two data sources, coffee chain and superstore sales, and the resultant set will have uh, the uh, only the the common fields between both the tables which have been joined from two two data sources. Okay, so that is about joins, uh, cross database joins and different types of joins. Okay, so we'll take a quick break of couple of minutes and we'll come back again and we'll see what a data blending is all about. So we have seen till now what a joining is. Now we will see data blending. You will see what a data blending is all about. Okay, yeah, right guys. So now we are going to look at concept called data blending. So what is data blending? So when you're looking at joins, so you joins combine the data from multiple tables in single data source up to 9.3. So however, if you want to combine the data from multiple data sources into a single worksheet, then we have to perform data blending. So if you want to combine the data from multiple data sources into a single worksheet, then we have to perform data blending. Okay, so what is data blending here? So in Tableau, so data blending allows you to combine data from multiple sources into a single visualization. Okay, so data blending allows you to combine data from multiple sources into a single visualization. So one data source is always taken as primary and all the other data sources are taken as secondary. So that the data source from which a field is first added into the view is automatically selected as a primary data source. So when you add a field into the view, so the data source from which the field you add first into the view is automatically selected as primary data source. That data source from which you add the field is automatically selected as a primary data source. So Tableau creates a relationship with fields from other data sources that have the same name and field type. So Tableau has a automatic feature of establishing relationship between the data other data sources. So there are secondary data sources apart from primary data sources, right? So if you use one as a primary, so Tableau automatically establishes a relationship between other data sources that have the same name and field type. If there is a common field between the other data sources and the primary data sources also, having the same field name and same type, so then it Tableau automatically establishes a relationship. If the field name do not match, in some cases the field name common field name doesn't match or even do not represent what you are looking for, so you can manually relate the data. So when you don't have a same field name and field type between different data sources, then you can manually relate the data also using manual uh, data blending. So if there is the condition satisfied, like um, the so to perform any blending we have two thumb rules. First of all, you need to look at those two conditions. What are those? Both the data sources should have a common dimension. Okay, so both the data sources which you are blending together should have one common dimension. Now that is one rule, and the second rule is in that common dimension at least one value should match. Okay, so within that common dimension, so there are multiple values, right? So in first table you might have a common dimension having one set of values. The second in the second dimension you might be having another set of values. However, at least one value should match between these two common dimensions. Okay, so this is the second rule. So if these two rules are getting satisfied, then it is possible to perform data blending. So this is a and condition. So the rule number one and rule number two should be satisfied compulsorily to blend data together. So the what is rule number one? Both the data sources should have common dimension. Okay, and the second rule is the common dimension should have at least one matching value. At least one matching value. If and only if these two conditions are satisfied, then only we'll be able to create data blending. Okay, so in Tableau, we can create blending in two ways: automatic data blending and manual data blending. So what is automatic data blending? In an automatic way, Tableau automatically performs the blending if the matching dimension is existing in the same case with the same name in the multiple data sources. So what is the condition uh, of automatic blending? So if Tableau is having the matching dimensions with the same case and same name of the field, common dimension field in multiple data sources, then Tableau performs the automatic way of blending. However, in manual way, Tableau performs the blending only if the user has defined the relationship manually. Okay, so a user has to define a relationship manually when there is no match between the field name and the field type. So in such scenarios, you have to define a relationship manually. Then in such type of relationship, we will be using the manual way of establishing a data blending. Okay. Basically, Tableau creates relationship with fields from other data sources that have the same name and field type. If the field names do not match or do not represent what we are looking for, you can manually relate the data. So first we need to understand how data blending or data integration works. So data blending, as you can see in the view here. So data blending is when you integrate data from multiple data sources into a single sheet. So multiple data sources are these. So these are multiple data sources. Okay. So say this is data source 1, this is data source 2. Okay. And this is the resultant single worksheet. Okay. Data blending is when you integrate data from multiple data sources into a single worksheet. The data is joined on common dimensions. So there should be a common dimension. So data integration does not create row level joins as like a joins. So in joins you create new columns, right? Okay. So here in data integration you will not create any row level joins, and it is not a way to add new dimensions or rows to your data. If you use a data blending, you will not be able to create new dimensions or rows to your data. So for that you can use joins. Instead, if you use data blending, uh, basically you have to you have related data in multiple. So when you use the data blending, so it should be used when you have related data in multiple data sources that you want to analyze together in a single view. So the only case where or the scenario when you use data blending is when it should be used when you have related data. You have related data in multiple data sources and you want to analyze that data together in a single view. So in that case you have to use data blending. So to integrate data, you must first either add one of the common dimensions from the primary data source to the view. Whenever you want to add integrate the data, so you have to add one of the common dimensions from the primary data source to the view. So say that this is the primary dimension to the left. So you have to add one of the common dimensions from this data source to the view. So that will act as a primary data source. So by adding a common dimension from any data source for the first place, in the first place, so that will act as a primary data source, because the field is coming from that data source. Then it will act as a primary data source because you are used that field in the first place. Okay, so for example, when blending actual versus target sales data, so think that this is actual and this is target sales. So the two data sources may have the date field in common. Think that, I mean, date field is the common field common between these two data sources. Okay, so the date field can be used on the sheet from the primary source. Okay, so first you need, if you use date field into the view, that would be uh, from the primary source. So primary source is this to the left, right? So if you use date field from the left sheet, left data source, so this will be created as a primary data source. Then when you switch to the secondary data source in the data window, Tableau automatically links fields that have the same name. Okay, so um, Tableau automatically links all the fields that have the same name and establish a relationship with the secondary data source as well, based on the common dimension. Okay, so we'll see that with an example. We'll connect to one data and open one more data. We've connected to two data sources. We'll look into that example in a few minutes. Right. So basically, uh, yeah. So if a date field can be used in on the sheet from the primary source, then when we switch to the secondary data source in the data window, Tableau automatically links fields that have the same name. Okay. So if the date field does not need to be used in the view, it can still be the linking field by switching to the secondary source and finding the broken link next to the complementary data. So a link will be established between the primary data source and the secondary data source common field. So if you don't want to use the date field, which is a common field in the view, it can still be the linking field by switching the uh, secondary source and finding the broken link. There will be a broken link between the primary source and the secondary source. So it will by clicking on the broken link, it will be establishing a link between both the primary and or secondary data sources. So this broken link will appear automatically if field names are same. However, so a link should be established between them. Okay. um, for example, if the desired linking fields doesn't have the same name, you can define a custom relationship that creates the correct mapping between fields. Okay, if the fields common fields doesn't have the same name, you can actually establish a or define a custom relationship that creates a mapping between those fields. So to define a relationship, we need to go to data. We need to go to we need to go to first connect to two data sources, select the table, then we'll get the data. Then we need to go to data, and we need to create the relationship between these two tables. Okay, so we need to go to data from the toolbar and choose edit relationships. So by choosing elect relation, we'll see that in detail. So by doing this, we can add the relationship manually. Okay. So for each data source used in the sheet, a query is sent to the database. So for each data source, so there are two data sources, right? For each data source used in the field, a query is sent to the database and the results are processed. Okay. Then all the results are related on a common dimensions. Okay, in a way that's similar to a left outer join. Okay, in the back end, what will be performed? A left outer join will be performed between these two tables or these two databases. Okay, so um, first all the queries would be sent to the databases and the results are processed, and all the results are related on the common dimensions in a way that's similar to a left outer join. The blending is done on the member aliases of the common dimensions. So uh, the blending is done in on what? On common dimension aliases. Member aliases means the if market is there and the aliases is central, aliases are central, east and south. So if south is having first letter as yes capital, so that would be checked with the region in other other table or other data source. So for example, south is having, see, having a alias with small letter as starting south. So this will be checked with what? So region in training superstore data, region aliases. So it should also have the same case and same name. Okay. So south should be matching. So here it will not match because the case is different. So it is having capital letter for south here and small letter for south there. Okay. So basically mm, um, the the blending is done on the member aliases of the common dimensions. So common dimension is region and member here. So the blending will be done on the member aliases here, central, east, international, south and west. So these are the member aliases. The blending is done on these member aliases. So if the underlying values aren't an exact match, they will need to be edited either in the data or using Tableau. So if the underlying values here are not matching or not exactly matching with each other, then we need to either edit in Tableau like this, or we can edit in the data source also, and then again load it into the Tableau. Okay, so this is how a data blending or data integration works in Tableau. Okay, in Tableau. So we'll perform different tasks and try to understand data blending better. So in the first task, we'll perform blending on Excel and text data source. So we'll take a simple example. This Excel data source has a products field which ABC as values and sales field with 100, 200 and 300 as values. And we have a text data source which is having products and profits. Products A and B, A and E. We'll take products A and E and 40 and 60 here. Okay. So I'm saving this, and so we'll connect to both the, so I'll open a new window, new dashboard. Here I'll connect to the Excel sheet. book 1. And also connect to the text file called test here. So I have two sheets in the two data sources connected to the dashboard. Now from Excel source, I will drag products into rows from Excel. So this is the Excel source. So I'll rename it as Excel. This is Excel, and this is text. This is text. So from Excel data source, I'll drag products into rows and sales into columns. Oh, sorry. I have to drag it from Excel. Products into rows and sales into columns. Right. From text data source, we'll drag profits into columns. From see the current selection is Excel. Now I will go to text. You'll see that a relationship has been established here between products in text table, text data source, and products in Excel data source. So it will be indicated by a orange link. A link is established here. Okay, if you check it, it will actually create a broken link. So by clicking on it, it will again create a link here. So a link from uh, text data source and Excel data source has been established between products fields. Now you can drop profits into the view also. Okay, profits into the view. So you have to notice here that in the text data source, we Tableau is indicating products with orange linked field. Okay, orange linked field. These products is indicated by orange linked field, which means Tableau has automatically performed the blending. So this is the first type of blending, which is automatic type of blending. So when there is a same name, so the same name is product here. This is a common dimension having the same name, and we'll also see same case. So capital A, capital E, and there's also capital A, capital B, and capital C. So same case and same name of the dimension. First condition is satisfied. And what is the second condition? There should be a at least one common value, A, B, C in products in Excel, A, E in products in text. Is there a common value? Is there a common value between these two data sources? If there is, what is that value? Can you please tell me? So what is the common value? So the values are A and E in products field in text, and the values are A, B, and C in products field in Excel data source. So what is there a common field, common value? If so, what is that? You can also see the view here. So only common value will have the data, and the rest of all will not have the data. So what is the common value here between Excel and text data? Hello, are you there?
Yeah, Grant, I'm here. What was the question again?
So the two conditions for blending data are
Mm-hmm.
both the data sources should have a common dimension, and
Okay.
and the common dimension should have at least one value which is matching. So the first condition is satisfied here. So the both the data sources is having common dimension called product here. Okay,
Mm-hmm.
products is the common dimension, and the second rule is the common dimension should have at least one value matching. So
Okay.
the products is having values A, B, and C.
Mm.
Okay, and in Excel, in text, the products is having values A and E. What is a common matching value between these two?
So you said one of the value was product, right? So I was matching
No,
with one.
no. So you see, the first condition is that the both the data sources. So the data sources are Excel and text here.
Okay. And
So
both of them have
within
product as a common one.
yeah, so product, it should have a common dimension, and you are able to see that products is a common dimension between these two data sources. So
Mm-hmm.
the first condition is met. Okay.
Yeah.
So what is the second condition? Uh, the common dimension should have at least one value which is matching.
Mm-hmm.
So in Excel, the products have the values called A, B, and C.
Mm-hmm.
Okay, and in text we have values A and E. Is there a common value?
A was matching the other one
Yes.
too.
Yes, A is the value which is matching. That's why even in the visualization, you're able to see the values for only A, not for
Mm-hmm.
B and C. Because in Excel we have A, B, and C as values. In text we have A and E as values.
Mm-hmm.
So the second condition is the common dimension should have at least one matching value. At least one matching value. So we have at least one matching value, A. So the
Mm-hmm.
condition is satisfied, right? Second condition is satisfied. So data
Yes.
blending is possible.
Mm-hmm.
Okay. So these are the two conditions that we need to check while performing data blending. Okay. Right.
Yeah.
Right. So this is also there are two types of two ways to blend data. That is, one is automatic way and another is a manual way. And here in this example, we are getting automatic. We are doing automatic way of blending data. So in the automatic way, Tableau automatically performs the blending if the matching dimension is existing in the same case with the same name in the multiple data sources. Okay. So what are the conditions to perform automatic way of blending? So Tableau performs automatic blending if there is a matching dimension in both the data sources. Okay. So is there a matching dimension in both the data sources? Yes, right? Product is the matching dimension, and and also it should be the same case. So products with capital P in Excel in text, and products with capital P in Excel. So both is having the same case, and it should also have the same name. So products here and products here. So it is having same name. Okay. So now it will have um, it can do automatic way of blending. How should we recognize that Tableau is automatically blending? Uh, uh, a link like this will be automatically established in Tableau. Okay, you'll be able to see an orange linked icon like this. So when you see an orange linked icon like this, then it is clear that Tableau is performing automatic way of blending the data. Okay, if this is not there, then you have to perform manual blending. So when a automatic um, way is established, you will be able to see this icon. So when will this automatic blending with this icon will get established? Based on three conditions. One is there should be a matching dimension between the both the data sources, and it should be of the same case, and it should be of the same name. Okay, if these three conditions having a common dimension with the same name and same case, if these three conditions are satisfied, automatic way of blending can be established by seeing this icon like this. Okay, right. So we have to note here that in data blending, Tableau will indicate the data source as primary data source and secondary data sources. So Tableau will indicate primary and secondary data sources like this. So a blue tick mark within a circle will indicate that it is a primary data source, and an orange tick like this within a circle but on the data source will indicate that this is a secondary data source. So what is a data source? It's a primary data source having a blue tick within a circle. What is a secondary data sources? Having an orange uh, circle and a tick inside it. So that will indicate a secondary data source. So there might be one or more secondary data sources, but there will be only one primary data source. So how will a primary data source gets created? If you drag any field from any data source into the view for the first time, that will be created as a primary data source. For example, so this is a new sheet. So if you take products from text will be a primary data source. Then if you take sales from Excel, so Excel will become a secondary data source. So this is one example. Similarly, so if in this example we have taken products from Excel, so whatever field that you take into the view for the first time, that data source will be taken as primary data source. The rest of all the data sources will be taken as secondary data sources. Primary data source is indicated by a tick mark within a blue circle on the database data source, and all the rest of the secondary data sources are indicated by a tick mark within a circle on the data source. So there might be one or more secondary data sources. However, there will be only one or single primary data source. Okay, right. Okay. Okay, so we also have to note that Tableau will combine primary data source and secondary data sources in the left outer join fashion internally by default. So what is the join type internally that will be calculated while you perform data blending in Tableau by default? It is left outer join between primary data source and secondary data source. Okay, it will have a join type like this: left outer join, left outer join. That means the all the tables from the left table, the matching data from the uh, all the values from the left table, and only the matching tables from the right table will be taken in a data blending. So this is the default uh, fashion in which data blending is performed internally in Tableau. Okay, right. So in data blending, first Tableau will perform the aggregation, then performs the blending. Okay, so first Tableau will perform the aggregation. So the values of sum, average, maximum, minimum are first performed, and then um, blending will be performed after the aggregated results are uh, got or retrieved from the databases. So also when we define any aliases, first Tableau applies the aliasing and then it performs the data blending. We have seen that data blending performs on member aliases. That means um, the aliases of the members of the common field are used to for data blending. So the data blending is done on the member aliases A, E, and so on. Okay, so if you define any aliases, so if you define any aliases like this: small a instead of capital A, small e instead of capital E, so these are the aliases that we define. So if you define any aliases, first Tableau applies the aliasing and then it performs the data blending. Because it is performed on data blending, the sequence is that first aliases are applied, then data blending is applied. Okay, right. So um, in data blending setup, so we'll add the dimension from the primary data source to the sheet. We'll add fields from the secondary data source to the field as measures or attributes. So we'll make sure either field names match or a relationship exists. Okay, so we'll add a dimension from the primary data source, and doing this will create that data source as a primary data source. Okay, so say left no, data source is a primary data source. So we'll add fields from the secondary data source to the sheet as measures or attributes. Okay, so once we add a primary data source onto the sheet, we will then add all the secondary data source fields onto the view, onto the sheet. Also, after doing this, we'll make sure that either field names match or a relationship exists. Okay, so either the field names should match between these two data sources, common fields, or if they don't match, we have to create a relationship. We'll see how we should create a relationship in few minutes. Okay, so how the blend works? So for each data source used on the sheet, queries sent to the database and results are processed. So for each data source used in the on the sheet, so a separate query is sent onto the database, and the query is processed. The results are processed. So then all the results are left joined on common key. So all the queries are temporarily stored and they are left joined. The query results outputs are left joined and blended into a common resultant set like this. And the um, and the join that is applied is left outer join by default in blending. Okay, so dimensions are on the sheets are considered for keys. Obviously, dimensions would be taken for common keys between these two data sources. This is how data blending works. Okay, so we will perform few more tasks to understand this concept. Okay, so we have also seen that to perform successful blending, we need at least one matching value, at least one matching value. Okay, so if you don't have any matching value, for example, uh, if you have F and E in text table and ABC in Excel table, and we refresh this, there's no, so there is no blending which can be applied. So we have just now tested the blending with unmatched values. So which is returning all nulls, which is returning all nulls. So to perform a successful blending, we need at least one matching value. So the second condition is at least one matching value should be there between the common dimensions, right? That condition is not satisfied here. So we are not able to perform any blending because there is no matching value, at least one matching value between two data sources. Okay, so in such scenarios, it will return all nulls and we will not be able to perform any blending like this. So okay, so we'll do one more exercise. So we'll test the blending with same matching value in different case. That means testing whether data blending is a case sensitive or not. Okay, so what is the case here? A, B, and C all in caps. In products, which is E and F. So we'll change this to A and F as it was before. In text, A and E, A and E as it was before. We will refresh this again. Right. So we will now try to test the blending with same matching values in different case. So we'll use products here. No, we'll use Excel and drag products here. And from text, we'll use profits. Okay. Even from Excel, we'll also show sales beside profit. Okay. We have a matching value called A here. Okay. So what we'll do is we'll go to text and change the alias and change the case. From capital A, we'll change it to small a. And now we are not able to see any value by changing the case. So now we have tested the blending with the same matching value in different case. So even in Excel, we have common value called A. A. A is the common value. Even in text, we have the common value called A. However, in text, we have A in small case. And in Excel, we have A in capital case. So we have tested whether data blending is case sensitive or not. The result is yes. Data blending is case sensitive. And the result is we are getting all nulls. The solution is to perform successful blending, we need matching value in the same case. So to get matching value in the same case, assign alias names or use calculation functions called upper or lower to convert the data to same case on both the data sources. So what we'll do, we'll change the case like this. We'll use aliases to name to keep it in the same case. So now we are getting the result. Okay, because there is a match between a value in Excel and a value in text, and both the values are in same case by changing it to capital A using alias. Okay, so now we'll test one more thing. So we'll test the blending with matching dimension in different case. Okay, so now we'll do it in a manual way. So we can go to data here and perform blending as well. So if there is no relationship which is established like this, so there is no relationship which is established here by having a broken link here. So we can go to data, click on edit relationship, and the primary data source is Excel here. So we can choose a primary data source here. So the two data sources are Excel and text. We can choose Excel as a primary data source because Excel is a primary data source here. So the secondary data source is text. It may have a single data source as a secondary data source, or it may have multiple data sources. However, primary data source only is one. So we can take only one data source as primary data source, but one or more as secondary data sources. We can have a list here. So we can go to custom here. So we can go to add, click on product and product, and click OK. Okay, and click on OK. So by doing this, when clicking this, a relationship between products in both the data sources will be established like this. Okay. Okay, we'll test the blending with unmatched or different dimensions having matched values. So when different dimensions having unmatched dimensions or matched values, if that is the case, automatic blending is not possible because the dimension name is different, right? So in the first place itself, automatic blending is not possible. Solution is to perform manual blending. The solution is to perform manual blending. For example, so we'll see that in an example with 3 data sources. So where there is no matching table, and for example, if you just use a product instead of products, so there'll not be a match. So there'll be unmatched dimension. So because S is missing in one of the dimensions, so we'll see that when we are blending 2 or more dimensions. Okay, so we have to note here that if you have more than 2 data sources, one data source will act as a primary data source and all the other data sources will act as a secondary data sources. Okay, so um, so now we will be performing blending on 3 data sources. So there are 2 data sources anyways here, so we'll create one more Excel sheet which is having product C. So this is having product and discount. So discount is 5%. The product is C here. Okay. Now we will add one more data source to the view. And we will name it as Excel2. Okay. Now, so this is one more data source added into the view. So we'll create a new sheet from Excel source and drag products into rows. So now we'll create a new sheet. So there are 3 data sources here: Excel, Excel2, and text. So we'll create a new sheet from Excel, and from Excel source, we'll drag products into rows. We'll drag products into rows. So if you have multiple data sources or more than 2 data sources, identifying which source is having matching uh, values with the remaining data sources, the data source will act as a primary data sources. Okay, if we have more data sources, we have to identify which source is having matching values with the remaining data sources. Then that data source will act as a primary data source. Okay, so I have to click on the text source. Now we will click on the text source. Tableau has automatically defined a relationship. So here, Tableau has automatically defined a relationship here. You can see that by the orange icon, link icon here. So Tableau has automatically defined a relationship. So now, so we can drag profits and drop into columns because an automatic relationship has already been established here. Okay. Now we'll click on the Excel source, Excel2 source. So here we can see that Tableau hasn't defined any relationship because can anybody tell me why Tableau did not define an automatic relationship?
Uh, in this S is missing, right? Product.
Yes. So the first condition is the name of the common dimension should be one and the
Match.
same. So it is not matching. The first condition is not matching. So basically that's why a relationship is not established here. So now what we can do is we have to um, drag profits and drop into columns. Now we have to drag discount and drop it into columns. Okay, now we are able to see a warning like this. Okay, so because Tableau hasn't defined an automatic relationship between these 2 data sources, we have to perform the blending manually. Okay, we have to perform the blending manually. We have discussed that there are two types of blending, right? One is automatic and one is manual blending. So in first case, where you are using Excel and text data source, we have performed automatic blending because Tableau has automatically defined a relationship. In second example, between Excel and Excel 2 data sources, we are not able to perform automatic blending because a relationship has not been established between Excel and Excel 2 data sources. For establishing a relationship, we have to perform manual blending. So what is the warning here? In order to use fields from Excel 2, a relationship needs to be created with Excel. Okay, so Excel 2 and Excel are two different data sources. So select data, edit relationship to open the relationship dialog box. Okay, so we need to first establish a relationship to make a manual blending. So we'll go to data, click on edit relationship by selecting the Excel 2 data source. So here in the mapping window, okay, in the relationship window, we need to, so now what are we doing? We are performing the manual blending. So blending manually. So we have to click on the data and then when clicked on edit relationship. By clicking on edit relationship, we'll get this dialog box. Okay, so in the relationship window, so this is the relationships window. So we have to select the primary as Excel source and secondary as Excel 2 source. So the primary as Excel source because it's already an Excel source, primary source here. So the secondary source are Excel 2 sources. So as I've told you, the secondary data sources can be one or more. So if there are more data sources, the list continues like this. Okay, but however, primary source should be only one. So now by selecting the Excel 2 data source here, we have to click on custom and then click add. So here we have products and product here. Okay, in the mapping window, we have to select products and product because there is not matching text here. So S is missing here. So we have to select these two and then click on OK. And again OK. Now a relationship has been established. You can see a link icon in orange now. How did we establish a relationship now? Using manual blending. So between text and Excel, it is automatic blending. However, between Excel and Excel 2, it is manual blending that we have performed, right? Okay. So from Excel 2, we will we already dragged discount into the view. Okay. So we have to note here that the primary and the secondary data sources are sheet specific. That means it will change from one sheet to the other sheet. So here the primary and secondary data sources are sheet specific here. So because I have used Excel or dimension from Excel sheet into the view for the first time, Excel is being considered as a primary data source in sheet 3. However, in sheet 4, if I use a dimension from text, so text would be considered as a primary data source. So the primary and if I use Excel here and then you drag sales into columns, so Excel is considered as secondary data source here. So the primary and so in sheet 4, text is primary data source. In sheet 3, Excel is primary data source. Did you notice the difference? The primary and secondary data sources are sheet specific. It will change from one sheet to other sheet depending upon the dimension that you have used in the view in the first place. Okay. So this is how you can do data blending in Tableau. Okay. So you have to note here that Tableau will indicate the data blending relationship with orange linked icon field. Orange linked icon field like this. Okay. If more than one matching dimension is existing, then it is possible to perform blending on the multiple matching dimensions. Okay. So if there are here you have only one product. So one matching field which is product. If there are more matching dimensions in the existing data sources, then it is possible to perform blending on multiple matching dimensions as well. So if you want to have matching dimension, perform blending on matching dimensions, you keep the link. If you don't want multiple dimensions, you just uncheck the link, so that a broken link will be there. Okay. If you want a blending, keep that link. Keep if you have multiple dimensions which are matching. Okay. Right. So Tableau performs blending by taking, so if you want to have multiple dimensions, so if you test the blending with more than one multiple matching dimensions, Tableau performs blending by taking multiple matching dimensions as blending keys. The final output of the blending is based on the matching values from multiple matching dimensions of blending key. So if you have multiple dimensions, you will have the output would be the blended uh, output of the multiple matching dimensions. So you have to note here that it is not mandatory to have matching dimensions or the blending dimensions in the visualization. So it is not necessary to have the matching dimension or a blending dimension in the visualization. So you may or may not have the matching dimension in the visualization. So you can remove that also and have the visualization in the view. However, this relationship here with the link should be established. That's the only key here. So also the important thing to note is in Tableau, all the evaluations are based on the aliases names. So in blending, the blending will be done on the aliases names. So that is important. So today we have covered about joining with different types of joins, um, um, within the database joins, cross database joins, different types of joins, equi joins and non-equi joins, and different types of joins called inner join, outer join, which is right outer join, left outer join, full outer join, and self joins. Okay, so we also seen what is data blending and how we can perform data blending, and what are the different conditions that we have to apply before performing data blending. So these are the two main topics that you will be using throughout when you are working on Tableau. So these are the most important topics you need to remember. Okay. So while we perform all the advanced visualizations in our next classes, so you have to keep these in mind, because in every data source, after you connect to any data source, you have to perform all these, either a join or a blending technique, to get the resultant data set. Okay. So obviously you will be performing all these techniques in your future classes. So please go through all these classes regularly. Okay. So you may also get some interview questions, or these are the important points if you are performing on real-time scenarios also. Okay, right. We'll meet tomorrow with a few more topics, few more advanced topics before we start performing actual visualizations, and then we'll go into the other topics as well. Okay?
Hey
Right.
Kranti, can you share that PPT?
Yeah, I'll do that.
Yeah, that would be.
Yeah. Thanks. Bye bye. Take care.
All right, thank you. Bye.